Hello everybody. So here it is. I've been talking about it and it's time to jump on it and get it done. What you're looking at is, yes, another SX1050 Pioneer receiver. The last one that I did there, I ended up selling, and I kind of regretted it after I did it. Had seller's remorse because I put so much time into it, and really it was a real good performer. So I saw this one a while back, and sorry about hitting this. Saw this one a while back and decided to go for it. I got a good price on it, and it's really beautiful. I've done nothing to this. I haven't even cleaned it. This is how it came out of the box when I received it. And if you look, little tiny bit of scratching there. The wood of the cabinet is beautiful. I don't think I'm even going to touch it. Maybe put a little bit of tung oil on it just to preserve it. But it looks to be all original. I don't see any work that's been done in it. I have not taken the cover off. I haven't even plugged this in or turned it on since I bought it. So this is going to be a lengthy process. We're going to go over every last little bit of this and try to restore it like new, or even better than new if we can. Also, before we start, I thought maybe I'd show you, we've updated the bench a little bit. As you can see, I added about another 3 inches of depth to the bench and put a whole new set of shelving up here. Redid the shelves. So this turns out really well. I have a nice 1080 webcam that I can swing down and get some other views for you. You saw the monitor back here. Got the test equipment set up in a little bit different configuration, and I even got the SG1050 in a more strategic position to work on. Here's a new addition to the bench, which is my Hakko FM206 rework station. And I'm still using my FX951. I really love this thing. It has been a fantastic soldering iron. This station, it outperforms anything I've ever owned in my life. The tips last forever. For how tiny it is, it outperforms my big Weller 240 watt gun. And if that isn't enough, this Hakko, this new one, has now an FM2030, turns out to be a 140 watt soldering iron, and this thing is unbelievable. I don't ever think I need anything between these two. I don't think I'll ever need anything else. The desoldering tool, the FM2024, the jury's still out on this. I'm not really 100% sold on it yet, but still testing it. And the not so good part of this would be the hot air gun. I was really looking forward to this, thinking it would perform as well as all their other equipment. But I can tell you that really, other than shrinking heat shrink, I don't know that I'll be able to use this very much for surface mount technology. I think a fly can fart harder than the air output of this nozzle, and it's shame on Hakko for having a top-of-the-line, top-priced product and turning out such a poor hot air gun. I mean, their earlier ones were so much better. But again, I'll work with it and see before I really get really upset with it. And last but not least, I finally got a good set of hot tweezers, which really I've needed for a while now for some of the surface mount equipment I work on at work. It's very hard to pick off a tiny little diode or a tiny little surface mount capacitor without something like that. It makes it so much easier and faster. So we'll be testing this out and using it, and we'll get to see how it really performs. here moving forward, starting with this. So what we're going to start with is just giving it a quick once over. I don't believe in turning anything on that's been sent through the mail or anything until you take the cover off and just kind of verify there's no shorts, there's no big problems. If there is something shorting in there or something, you don't want to turn one of these on and risk damaging something that otherwise would not have been damaged. So that's what we're going to do. Get covers off, inspect it visually, and then slowly bring it up on a dim bulb and make sure that everything tries to come up properly. And then we'll assess the situation and see if there's any repairs, which I'm not expecting any, and we'll get to work on the restoration of the, of course this is going to be an electronic restoration. Physical restoration, cosmetic, not very much to do. It's a very, very clean system. Just a little bit of polishing and cleaning and it should be good. So this might be a good opportunity for anybody who's starting to get into audio and restoring vintage receivers. We'll go over the way I test it and the way I adjust it, what things that I feel that I like to replace as a preventative maintenance type thing, and how, what I replace them with. So if that sounds interesting to you, then this should be an interesting video for you. If not, you've already seen the last one I did. The video didn't turn out so well because it was one of those ones where I uploaded it to YouTube, and when it processed it, for some reason it made it all choppy. It plays perfectly smooth here, but as soon as I uploaded it, it did that. I tried twice, it didn't really fix it much, so I just left the video up as it was. Hopefully this will be a much better, more stable, viewable video, and should be a lot easier for you guys to watch. And I won't be on the handheld camera for the rest of this. I'm just doing this now because I need to get back far enough to get everything into the shot. As you can tell, this is a monster receiver, and it takes a lot of bench space, and it weighs about 55 pounds. So heavy piece of equipment, well built. All right, let's get it apart and get started on this. All right, we're inside, and I just wanted to kind of show you with absolutely nothing done yet. I haven't even cleaned the dust out of this. This is how clean this receiver is. I'm really surprised how clean it is. It doesn't look like anybody's really been in here. I don't see any brush marks that somebody was brushing or cleaning anything out. It just looks like this amp is just this clean. I don't see at the moment any kind of components that have been replaced or serviced or anything. So I think this machine's pretty much as it was built in the 1970s. I think this is a 1978, 79, somewhere around there. I'd have to look up the dates that these were made. I mean, the most dust I see is right there on that capacitor. If it'll zoom in, and you can see a little bit of dust there. That's it. So really, this is a good candidate for for, I won't even call it a restoration. It's just kind of a updating a little bit. Talk about some of the components in here from my experience. All of these capacitors here that are this orange color, if you look, you zoom in, see like this one here, these here. Those are very, very high quality capacitors. Very rarely do you ever see them fail, or I have never seen one fail in any Pioneer gear that I've ever worked on. But most of those ones are the critical in the audio path, and I always kind of don't know whether I should replace them or not, because when they're new, they work very well. But, when you're replacing components and kind of redoing one of these receivers, you're doing so that it will last for many, many more years. And, sometimes I think to myself, well, it hasn't failed yet, so it probably won't fail. But then again, it hasn't failed yet because it hasn't failed yet. So, technology of how they build capacitors today has come such a long way since these were built. The capacitors are so much better. They have lower, the electrolytics have a lot better ESR properties, things like that. So, long story short, I usually end up replacing most of the capacitors in one of these, even though it's not 100% necessary, and some people feel differently about that. It really is a judgment call. But these orange ones here, if you're going to replace them, you better buy the most, the best quality that you can. Now, I don't mean these boutique capacitors. I'm not a big advocate of those because I think at some point in time, you're just wasting your money on something because somebody says it's better. Special oil capacitors that are big, huge things, and people cobble them onto these boards. I think it looks bad. I think it detracts from it, and I don't think it improves the performance very much. But that's me. Other people feel differently about that. So we're going to go through and just dust this lightly, and then we're going to bring it up on a variac, or on a dim bulb at least, and just see if this thing will work just as it sits. Okay, I blew the dust out of it, and as you can see, I have the transformer here really clean. Now I'm going to show you a little tip that I use to clean off some of these painted metal surfaces and some of the wooden surfaces, things that are non-electronic, that you're not going on to circuit boards or wires. But what I use is this hand cleaner. Okay, you can see it's just liquid, kind of like a gel, and you can buy it at auto parts stores and all kinds of places. And you just take a little bit, and you just take a little terry cloth towel, take a little bit on it, well, just a tiny bit, you don't need much. And yes, don't panic, I'm doing it over top of there, I'm being very careful. And you just go on here with a little bit, okay, and get rid of the excess. And then you get a dry part of the rag, and you just kind of rub it around and clean it. And as you can see, it brings everything just back like new. It does a beautiful job. And it almost makes it look factory original. Cleans it right up. Especially if you have that grungy dirt that gets kind of sticky and is hard to wipe off. It works really good for things like that. It also works very good on these surfaces like the metal. And you can see the difference it makes. So you can see where I stopped here. And you can see if you just go down the line with it, and there you go. And I just have it barely dampened with that, with that hand cleaner. I don't have a whole ton, so you notice it doesn't leave a big wet spot. It's just enough to clean it. And you can see it does a beautiful job. And there you go. So again, it's the little details like this that makes these amplifiers really nice. It makes them, something to be proud of when you finish a job like this. Or if it's something that you're going to sell, it'll increase its value, because when not only does it work well, but it looks good, to me, there's two parts to restoring something. There's the electronic, which is the most important to me, that it functions as best as it can. But also there's the physical restoration. You want it to look really nice. I mean, this is an expensive piece of gear, and if somebody's going to spend a high dollar amount to purchase it, they want something they can show off and be proud of. So take the extra time and clean it. I mean, it makes a big difference. And plus, when the machine's clean inside, it's so much easier to work on. You're not getting stuff all over your hands and, you know, making everything messy. It's so much nicer when this thing's, you know, when it's clean to be, you know, as you're working on it. So, all right. So I'll finish cleaning up, and then we'll do a power up. All right. So we're going to have the world's simplest power up. Now I'm not connected to any dummy loads. I just have the receiver sitting here by itself. And I'm plugged into my dim bulb connector, and I'm set on limit, which means we're in series with our little dim bulb. Now, this is going to be quite a power up, because if this is working properly, what's going to happen is this bulb, this filament, is going to get really bright. It's going to max out the limit of this bulb as these two big, huge, gigantic capacitors charge up. Now these capacitors are somewhere in the line of 22,000 microfarads each at 80 volts. And they're going to charge up probably to about 62 volts each. So positive and negative going power. At first, we have a soft start circuit in here. I think I talked about this in the first video series I did on these amps. And this resistor at first is going to be in line with these capacitors to limit the inrush current. If not, we would blow the circuit breaker in the house, because most house circuit breakers are either 15 or 20 amps, and these capacitors for a split second can actually draw in excess of 100 amps, more like 150 amps or more for a split second, which can pop your breaker. So this resistor limits the inrush current for just for a second or so. And then if you look down here, we should hear this relay kick in, and all it does is it shunts out that inrush current limiting resistor and permits the capacitors to complete their charge all the way up to the maximum voltage. Now, even with that resistor in here, you are going to draw a very large amount of surge current at first. We call that surge current or inrush current into the capacitors. This is a function of a capacitor. You know, at first it acts as a short to the circuit, because basically it wants to charge up as quickly as possible. It wants the voltage across the plates of the capacitor to be equal to the voltage being applied to it. And so therefore the current at first is very, very high. Okay, so the current leads the voltage, meaning while the voltage is building up from 0 to the rated voltage, the current is doing the opposite. It's maximum at the beginning and then drops down as it charges. So you're going to see that reflected in this bulb. Now I've never turned this stereo on yet, but if it's working properly, we should see a very bright bulb. It should dim down. You should hear a click on the relay, and then everything should go back. This should get much dimmer. So I'm going to throw the switch right now, and we're going to watch our bulb. Did you hear that? And that's it. Now let's try it again. I'm going to shut it off. You're going to hear one quiet click, which is the first relay that shunts out that resistor. And then the second click that you hear is the protection circuit saying everything's okay. So let's do it again. You ready? Now these caps are a little bit charged, but here we go. Hear that? Very good sign. And if we look down here, we see our panel lamps are on. Now we're still being limited by the bulb, so we certainly can't run the amp right now, because the bulb will cause the protection circuit to kick as soon as it draws current. But this is a really good sign. We don't have any shorts in this stereo that we can see right now. So our first test is done. So let's get set up to check a few more things. Okay, so for our next test, I have a set of speakers hooked up, and I have a couple of signals. I have my Talking House AM transmitter, and it's set up at 800 kilohertz, broadcasting some material. And I have my FM signal generator set up to generate a tone at a 100 megahertz. So what we're going to do is, first of all, we're going to turn on the stereo and see if we get any sound. I'm direct connected with my power. I'm no longer using a dim bulb, so you should hear that first relay click in almost instantaneously after the initial surge current. And then we should hear the protection kick in after that, and we should be able to hear some sound on the speakers. So let's do that now. So power on. There we go. Okay, so for right now, as you can see, we're set to AM, and I should be able to get somewhere right here on the 80, where it says 80, that's 800 kilohertz, and that should let us pick up our little transmitter down here. So going up with the volume. Yep.
During the next 12 months, the need is especially urgent for experienced mates, engineers of all classes, able-bodied seamen, firemen, oilers.
Okay, so there's our little channel, and as you can see, our dial is off a little bit. It's reading a little low. We're at about 790, something like that. I don't know, a little bit low. But
experienced merchant seaman who is now working on land returning to the sea.
But we can definitely hear it. So let's switch over to FM now. You can see here I'm going to switch FM. And right around 100 megahertz, I'm going to take my little loop antenna here, as you can see. I'm going to just hold it right above the camera here. And the amp should be able to pick it up because I'm right over the tuner area. Alright, let's see what we get. Again, this should be 100 megahertz. Well, that's pretty good. I'm at negative 20 dB right now, dBm, and you can see I'm getting a nice little signal. It's center tuning, but once again, the dial is a little bit off. Not quite as bad as the AM, but off by a little bit. So other than our dial indicator being off, our tuner seems to be working. And we have, as you can hear, we have a little bit of static, so we have, we may have to clean it a little bit, do some cleaning. But so far so good. Now, we also can inject a stereo signal, but we're going to do that later. I just wanted to basically see if the amplifier works and if the tuner can at least pull in, pick up a station. And it does. So this is all good. It's good stuff. So, we're going to take this apart now and do some of the customary cleaning and so forth. The amplifier is on right now, and again, do not reach inside of any energized equipment unless you know what you're doing. When you work on this stuff, you're doing so at your own risk, to use the phrase of others who've posted videos. But I just want to kind of check and see, and of course I can use my digital thermometer, but I'm using my analog thermometer right now. And these both feel warm, and you'll find out on these SX1050s, these driver transistor sections will run warm, and as you're running the amp at high volumes, they will get very warm. That's just the way these things operate. If you remember on my last one that I did, I actually had to when I purchased it, it had a blown channel, it had all kind of bad transistors. I had to replace them, and at that time I put bigger heat sinks and different, heavier duty transistors in here. It worked much better. But these have worked for years like this. I'm really not going to change any of the semiconductors in this amp unless I see the need to do so. And only after running it for a while will we know that. I will, however, recap the entire power amplifier section as a precaution, and the main reason is the capacitors dry out. These are excellent capacitors. All the components used in these amps were the finest at their time. Very good quality. And, you know, nothing wrong with that. But, you know, this thing's 1970s technology. It's 40 years old, you know, 30 plus years anyways. And I don't want to have this ever fail on me. So what we're going to do is we are going to do some preventative maintenance by replacing those capacitors. Probably on this one, this looks like a very low used unit. So I would imagine all the signal path capacitors in the tuner and down, especially down in the tone section and preamp section, they're probably going to be really good. Any of these orange ones I'm really not going to mess with because they're typically always good quality and they sound fantastic. I don't see a reason to replace them. But anything that involves power, like these ones, they will get replaced as a precaution, because we want this amp to last many, many years. I want it to be in a museum one day to show what good audio equipment used to be like a long time ago, when it was all hand wired like this, you know, with the individual discrete components. So by doing a little maintenance now, we can assure that this amp will be here for many years to come. These are notorious for having problems with the small semiconductors. Okay, they do fail and have failed, as you've seen in my previous videos on the, you know, on the SA series ones, the 8500 and the 7500, and on the SX1050. You know, a couple of those you saw where we had some of the small signal transistors were bad. This amp does not appear to have a problem with them, but it wouldn't surprise me down the road if we do have a problem. But those I don't replace unless it's necessary to replace them. You know, as long as, and really another reason that some of those transistors fail is because, you know, the capacitors get leaky with age. You know, they work, but they draw a little excess current through that circuit and change the bias point and cause those to fail. So not all the more reason to recap this thing. But really, we're not going to have a whole lot of work on this thing. Mostly cosmetic, you know, cleaning the controls and replacing the power related capacitors, and then going through and making sure it's properly aligned and everything's working properly. And then we'll do a performance test, and I think this one's going to end up on my on my stereo rack, and I may take down the SA8500 and its and the TU or TX8500 tuner, because this actually is a really nice receiver and I like it. So anyway, that's where we're at. We'll get some things tore down and get started. Okay, so one of the things I'm going to try on this video is I have a new position for my camera mount that's off to the side of the bench that kind of looks down from a side profile of the bench, and kind of lets you really get in and see what I'm doing here. So I have the amp turned around with the rear of the amp facing me, the rear of the receiver, and we're going to disassemble this board and take it out in order to do the recap and so forth on it. So I just wanted to show you, to get this particular board out is really only 3 screws. There's one screw here, one screw here, and a third one right here that you can just see. You take those out, and then there's a little retaining clip like that on the bottom of the board, and this board will lift out. Now, here's the thing. Down below there, if you look, let's see how, if you look down in there, it's hard to see, but you see some of the wires? All the way across the bottom of this, there are little pins sticking out down this way, kind of like that, and there are wire wraps with all the wires and all the signals and voltages going into this board coming in from the bottom. So we're going to have to flip this over, and the first thing we have to do is disconnect the transistors. So This heatsink with your output transistors, there's 8 of them on here, connects to this board with 8 of these plugs. So you have one plug, I believe. No. Each pair of transistors connects to one plug. So we take these 4 plugs off. Then we will have to loosen a couple wire retainers, retainers down in the bottom, and we'll see that here in a minute. And then this board will be ready to come out. Now it's not going to come all the way out because, again, unless we wanted to unwire wrap those wires, and we may do that. I did that on the last one, and then I reattached them. But we can recap this in place if we want to. You will have to, however, take this heatsink out, and it comes out after you get the board decoupled. There is enough space in the wires to move this board away, and then there are 4 screws, 1, 2, and 3, 4, that takes the heatsink out. Okay, so we remove the heatsink and the output transistors, and then we'll be able to clean those and re-grease them and put new pads on and everything. Make sure they're good. And then this whole board will be just have all this empty space in here for us to work. So we should be able to get in there and remove the capacitors and put the new ones in, test anything we need to test, reflow any of the cracked joints that there may be, from them being old. Sometimes these up here will get cracks, and you'll get noise, and you'll get intermittent things, and that causes the transistors to go bad. So we check all that out, and then we'll be able to reassemble this, and the whole amplifier section will be done. The fun part comes when we get to the portion concerning the tone control and mode select and volume and all that up in the front underneath, because you'll see that these boards are kind of they're sandwiched in under there in layers, and you have to kind of take them out, one layer at a time. And there's a lot of wires and a lot of things in the way, so it can be very difficult to, to get to everything. So we'll see how that all goes, and hopefully you'll learn a little bit about these and what goes into a proper restoration. Now, once again, this one's an easy one. If you were a rookie, this would be a great way to get a new receiver that because you're not going to have to. I have a feeling I'm not going to have to do a lot of troubleshooting. Most of this is going to be maintenance. Unlike that SX1050, if you recall what we got into on that with the tuner, with the amplifier, with all these things, it just had multiple problems. And but it turned out like better than new when we were done, didn't it? So anyhow, let's carry on. Okay, see if we're recording here. Just want to make sure. Okay, so I've got the bottom off. I've had this big, heavy, huge amp lifted and flipped around, and just a couple little dust bunnies. You can see there hardly any at all, and wow, I think what you're going to see here is one of the cleanest examples of a receiver of this era that I think I've ever seen in my life. This amp is absolutely pristine, to the point where the screws, if you look, the screws look as if they have never had a screwdriver in them. When I took this thing apart, these screws were factory set. You can tell they had never been removed. This whole receiver is absolutely pristine, and I have the feeling that whoever owned this prior to me purchasing it hardly, if ever, used it. You can kind of tell from marks and stuff and heat and dust and so forth when a receiver has really been used. This one has hardly been used at all. I would argue that probably a lot of the components in here are still like factory new, including the capacitors. But once again, I will, as a precautionary method, I will just, like some of these bigger caps here, like on the bottom of the main power supply, a couple of these ones. This one is, these especially down here, I have seen them leak on other ones, other examples, and I don't ever want to see that happen on this if we start to use the amp. So I will replace them with modern ones that are, modern capacitors. Technology has really improved. You'll notice the new ones are going to be a lot smaller than these, and yet they're going to be better quality, longer lasting. But of course, to say they're longer lasting, these are 30, almost 40 years old, 30 plus years, and they're still going strong. Now, on amps that have been used and well used, yeah, they do have signs of wear on them. But again, take a good look, guys, because this is about as clean of an example as you're ever going to see of one of these receivers in its original pristine condition. Again, this thing looks like somebody just took it out of the box and shipped it to me. You can see there's not even any tarnish on, anywhere on the case or anything. This foam's deteriorated, as you would expect, but even the wires where they wire wrap onto the terminals are silver, are bright, shiny silver. I mean, I don't know if I can bring you in close enough to show this, but just look at those wires. Sorry about the shaking here. Let me get zoomed in. But look at those wires. I mean, they're perfect. Normally, you would see a dull silver by now. They tarnish. The metal actually tarnishes on these as they age. But this doesn't even have any tarnish on it. So, yeah, like I said, this was quite a find. So far, I'm just amazingly pleased with what I'm finding. So, I don't know, guys. This isn't going to be much of a video, other than watching me test this thing and change a couple capacitors. That may fail if you really start using this. I'm not at liberty to really do much else to it. I may not even touch the tone section because a lot of the capacitors in that section aren't subject to much voltage. And as far as sound is concerned, we'll give it a test, and if it sounds fantastic, I'm not going to play with it. I'm going to leave this original. Other than the power amp, that's a known. These and the power amp are known issues on these. Those capacitors have a lot of stress on them. They have very close to the voltage that they're rated at applied to them all the time. They're, if you're lucky, they're 85-degree caps instead of 105. So they will fail eventually. They did just because of the age. But other than that, I'm not playing with this, and I'm going to try to do as neat of a solder job as possible so that it looks untouched, other than seeing the new style caps on there. So that's what we're going to do. As you can see, here's the little fingers we were talking about. In case any of you are going to work on these. And again, the 850, the 950, the 1050, I mean, even the 1250, they share some things. The 1250 has the heat sinks on the sides, but all of them, have similar mounting techniques to the boards. As you can see, these are just little hooks that the bottom of the board connects to. You can see that hook there. And those top 3 screws are all that holds it in. Now all we're going to do is we're going to remove these wires from the little retainers very carefully so that we have a little bit more room to move, and we're going to take our time getting this apart. We're going to pull the heat sink, and then we're going to just replace those few power caps on there and put it back together. So enough babbling and talking. Let's get to work. Okay, so as you can see, we have these disconnected. I took the 2 thermal sensors out, removed them. All right, and we'll zoom in a little better. I took the 4 screws out of the sides, disconnected these, and loosened the wires off of the retainers down in the bottom as I showed you. And now, after just kind of moving this board a little out of the way, we should be able to just lift up see. And there's your whole heatsink assembly with your original output transistors. Now again, these transistors were very, very high quality. I do have heavier duty replacements that work perfectly, but quite frankly, these transistors look, I believe when Pioneer made them, they did match the transistors. They are matched sets, and very clean sounding, low noise, very, very good current capability. Basically, I'm just going to clean them up, clean the grease off, and check the pads, and then remount them with new heatsink grease. And I'll do one transistor with you all to show you how we do this, and then I'm just going to put it back as is. No need to replace these. Now on the other SX1050, we did have a problem where a couple of these were dead shorted, and they caused a lot of problems on the power amp board that I had to do. Some of that was done off camera, the troubleshooting for it, but it was quite a bit of work. This one obviously is not going to have anywhere near that kind of work to do on it. But as you can see now, we have pretty good access to this board. Now it may be a little bit difficult to get to all of these here, but I'm going to try to not touch the wire wraps, because as I showed you, they're so pristine and perfect. I really only need to get a couple of these caps here out, and I think I can flip this amp over and get at them from the bottom through the access hole in the bottom. So we're going to replace those and check these out, make sure they're mounted properly, make sure the grease is still good on them, and we'll put this back together, and that part of it's going to be done. It's a simple restoration on this guy. Alright, as you can see, this board just popped right up through this access hole down in the bottom, so we don't have to take anything out, and I don't have any major things to do, so I'm just going to replace these couple of capacitors and just leave well enough alone and put it back together. So I just thought I'd show you that. I'll demonstrate the new Hakko FM2024 desoldering tool, and we'll see how it works on these kinds of boards. Okay, so I'm zoomed in on the board on two of the capacitors that we're going to be replacing, and we're going to use this Hakko FM2024 desoldering tool, and we're going to see how this thing works. This is kind of the first real workout that I'll be giving this thing, so let's see what we get. That's it. Just fell right out. So, well, that worked out pretty good. So let's pull this capacitor out. And they are marked on the board, and it is in the correct orientation. And here is our first capacitor. So you can see this is only a 6.3 volt cap, 470 microfarad. And you know, just to give you a little idea, so if you look here, here's the old 6.3 volt, and here's a modern 470. See them together? And this one's at 25 volts, as you can see. So you can see how much the size has changed. And these Nichicon Gold capacitors, this is a, what's this called? The FW series. Alright. I don't know if we can zoom in on that or not. Come on, focus. There it goes. FW series. Very, very good capacitors. They hold up really well. They last a long time. They don't leak. Really good quality. And then we also have the Nichicon FR series. Let's see if we can get it to focus. And these are the FR series. And they're, if you notice, they're 105 degree. Now, the main difference between these two types of capacitors, and I know there are a lot of people out there who overreact to capacitors and underreact to capacitors, but I'll kind of give you my opinion on it. As you notice, they look very similar. They're made by the same company, so why would Nichicon bother making different types of capacitors? Okay, and there's a simple reason for that, and that is that different capacitors are good at different applications. And the reason I say that is you have to look at things like the amount of ripple current, the amount of temperature that they're going to be in, you know, a lot of the frequency that's going to be applied onto them. All those things, different capacitors have different strengths and weaknesses. So for instance, those gold capacitors are very good, you know, for things that are used in low frequency in the audio path or something like that. They also work good in situations where you'll have you know, higher frequencies on, like if this was going to be used as a decoupling capacitor on the output of some amplifiers. Some amplifiers have to have a decoupling cap between the speaker and the output transistors. These kinds of caps will work very good for that. Whereas these other ones work very well on, you know, on linear power supplies, where, you know, you may not have high frequency, but you may have a lot of ripple current as it draws loads, and it may be in a situation where the temperature is higher. These have very, very, very long life. Okay, so from a sonic, you know, standpoint, like if you're using it in an audio path, it may not perform quite as well at the higher frequencies, but for filtering capabilities in a power supply, these are very, very, very long living capacitors. So depending on the application of this capacitor in here, we will choose one or the other. And hopefully we can look at some schematics, and those will help us to make that decision, and I'll show you how I make that decision. Alright, I have a printout of the power amplifier assembly here, and bottom line is what we're looking at is these four capacitors here, 1, 2, 3, 4 for the two channels. And if you look here, one of them says 470 at 16 volts, the other one says 470 at 6 volts, and they're both similar looking capacitors. The one we have right here is the 470 at 6.3 volts. As you can see, it's upside down. And if you look in here, they do have something to do with the audio path, but not really so much. These are, if you look here, is your output over here. This coil and this resistor kind of work together as like a choke circuit, and the output of the amplifier goes through that. Okay, so if you traced it through on the big picture, which this is a really teeny tiny capacitor, you know, it's, even though it's a 11 by 17 print, you can see how tiny the print is on this thing. But you can see basically your protection circuit is here, then it goes out to the speaker assembly, but your inputs going into the protection circuit right here through your main relays, there's your relay that goes to your speakers, it goes straight back to this coil. Okay, so that just shows you that your speakers in a roundabout way are directly connected to this line, and you can see that this capacitor these two capacitors here are picking off, or basically filtering, this input of this transistor right here. Okay, it's kind of a I'm not sure, but I think it's used for some type of feedback is what they do with this. Okay, so it kind of works like feedback. And these transistors are in pairs, as you can see, and they're similar to those ones that we had to troubleshoot on the SX1050. But if you notice on the board on this particular amplifier, all of these paired up transistors that work together like this, they are matched, but they are discrete separate transistors. Okay, and they basically are not in those single packages. If you remember those single packages where you had the two transistors in one case, and we had the debacle of getting the ones that were wired backwards, and they had the same part number and all that. If you go back and watch my SX750 video, you'll see that. I believe it was the 750 that we had that problem. But on this amp, no problems. It has the discrete transistors on it. So once again, these are not going to have a particularly high voltage on them. This one being only rated at 6 volts, this one rated at 16, and I'm not really sure on the schematic why it says that. If you look, all 4 of these are all rated at 6.3 volts. So again, that might be a typo on the schematic, but it's written twice in there. This one says 470 at 16. This one says 470 at 16. And if you notice, they're in parallel with one another. So really, what they're trying to do, what they're trying to achieve, is they want to have a high capacitance, which is 1,000 microfarads, and there's one of 2 reasons why they did this. One reason is they want a really, really low ESR. Okay, by putting multiple capacitors in parallel, you are actually, it's the same from an ESR standpoint, or equivalent series resistance standpoint. It's the same as putting the resistors in parallel, so your resistance goes down. Remember, when resistors are in parallel, the resistance goes down. Okay, so this reduces the ESR. The other thing is, you remember when this amp was built, large value capacitors had large size. So the other thing is, if you wanted a 1,000 microfarad capacitor in here, they would have to be relatively large in size. Now, being where they're mounted on the board under here, if you look, you really have a lot of real estate there. You could probably have mounted one single 1,000 microfarad in there. So my guess is they did this in order to reduce the ESR for whatever reason in here. Probably because there is actual sound, in the sound path. I mean, there's a 56K resistor here. I mean, there's not much current at all flowing here, obviously, because you're going into the base of this tiny little transistor. However, they probably want a very low ESR because of the higher frequency that will be presented across this. Now, what this indicates to me is this is not a filter capacitor for a power supply, like as you would think, filtering ripple off of a power supply. Okay, this is actually, looks to me as an RC filter that is used, to clamp the input of this little transistor here at the base of the transistor. And this probably has to do with feedback. Okay, so really this is going to have high frequencies presented on it. So therefore, in this case, I would use the gold, or the FW series capacitors, because I'm looking at something that's not going to have a lot of stress on it, but is going to need to have low ESR and need to have good capabilities on higher frequencies. And what you'll find, I think, if you when I go to, I'm going to eventually get to do a capacitor video, but what you'll find is when you put these on a capacitor tester and you check them at different frequencies, with electrolytic capacitors you will find that some capacitors roll off very quickly when you get above 120 to 200 hertz that you're applying across these, of ripple. As the ripple increases, these cannot keep up, and a lot of it has to do with the ESR. These are very low ESR capacitors. They're gold because gold always stands for higher quality, but that's kind of a sales gimmick. But really, these are the ones you want to use in this instance. Now, if I put those other ones in, will it not work? Sure, it'll work, but what you may notice is it may not perform at the level that the circuit was intended to perform. Okay, so in that case, I'm going to use these. Now, these are 25 volt for the maximum voltage. These are only 6.3 volt capacitors, and no matter what the typo is here, this says 6 volts, this says 16 volts. They're both 6.3 volts. Okay, so again, going a little bit higher in voltage is never a bad thing. It doesn't hurt. But remember, if you go too high and you exceed it by too much, these capacitors will never get the proper amount of voltage on them to stay formed properly. And you can run the risk of them failing early because of that. Okay, so would I put a 100 volt capacitor in here? No. Would I put a 50? No. 25 is pushing it. Probably a 16 volt would be even better, but these are what I have in stock. They're going to be fine. But that's what we're going to put in here. We're going to do these gold ones. Okay. Again, if this was a power supply filter, I would have used those 105 degree ones that are, rated for a lot of current and going through them and a lot of heavy ripple and things like that at line frequencies. Okay. So again, there's so much more we could talk all day about capacitors and those things. There is a difference, even though some people may tell you there aren't. Now, I don't subscribe to the crowd that buys the $100 0.1 microfarad capacitors because they think they sound better than the $10 or $5 or $2 ones, but to a degree there is something to that, okay? But at some point, it's diminishing returns. You're not going to hear it with your ears, in my opinion. So anyhow, let's get these in, and let's move on. Alright, so I'm testing out these main filter capacitors. I got all the other caps replaced in this board. And so the first thing I did was I checked them out on the Sencor capacitor checker. This one is reading in at about 19,000 microfarads. This one's reading at about 21,000. So they're pretty close. ESR is absolutely fantastic. I checked leakage current. Leakage current is about 810 microamps on both of them at 50 volts. And connect this up to the ESR meter. And let's see what we get. This is the negative capacitor. If you look here, look at that. Super low ESR. Look at that, 0.008 ohms, 8 milliohms. So for that capacitor, we're good. And for this one, 3 milliohms. So as you can see, these capacitors, in every possible way that I can test them, are absolutely perfect condition. So I see no reason to replace them. I do have brand new replacements for these if I need them. I have a couple different types, but looking at how these ones are, I don't see any reason why I would replace them. So they're going back in, they're staying in, and we're going to leave well enough alone on these. Alright, so we're back here with the heatsink out, and I'm going to show you something on this. Now this may seem really boring to some of you, but the reason I'm putting this in the video is because I had several questions probably several months ago about how to properly apply and clean heatsink grease and the mica insulator pads. So I want to try to help some people that are kind of new to this. I've received an awful lot of messages and emails and all different kinds of communications of people that are very interested in learning how to restore vintage audio equipment like this, kind of as a hobby like I do. So one of the big questions that comes up a lot is how to deal with these sorts of things, and so I'm going to go over this. It's going to be maybe review, maybe boring to some of you, but it may be useful information to some others out there. So first of all, I have the heat sink out, and I'm just going to kind of show you how these are put together. If you look on the back, we're very fortunate in this instance in that they're using actual sockets. Just like tubes have sockets, these big transistors can also have sockets, okay? And even in the really old gear, you may even see the little small signal transistors and preamp transistors have little tiny sockets that they're plugged into as well. But a lot of times on these big amplifiers that use these TO3 type transistors, TO3 is the signifier for the case style of these transistors. But these TO3 transistors will often have these little sockets, and you can see there's 2 pins on them, and then the outer case on these transistors is actually one of the 3 conductors. Usually the collector of the transistor is tied to the case, and then these 2 other pins here and here are your base and emitter. Now when we remove these, it's very easy to take them apart. On some other systems out there, they simply just put the insulator pads with some insulating washers, and they screw the transistor directly down to the heatsink and then solder the wires directly onto the pins. Those are a little more challenging because of course you have to remove the wires from the pins and then reattach them to the transistors when you're done. But in this instance, you're going to see how easy this can be. So really all you need to do is we can take a screwdriver here and we take out the 2 screws. Alright. And then you just need really a relatively thin screwdriver. Okay. So something like this. And you just kind of pry up a little bit on these. You can see how they're already loose. Now be very careful when you remove these. If you're prying under here, these mica pads, mica is just like glass. It will crack and break very easily. So don't dig into the pad. Don't try to grab this from the sides from here. Be very gentle. Okay. So you can see we're above the pad, and it just pops out that simple. Okay. Now one thing I'm seeing here is that in this particular instance, again, this is really abnormal for this receiver. By the way, guys, I was wrong. It was built in 1976. So, as of this year, this thing's old. So, you're talking 40 years old. I mean, that's pretty darn good. 41 years old we're coming up on for this receiver. And to see something in this good a shape, this would probably be a condition here where I would have left this alone. The grease on this, the things you really want to see. When you remove these, a lot of times this silicone grease, which is a paste, will dry out. When it dries out, it kind of starts to lose its properties for conducting heat through the insulator. Now, why are we doing all this? As I said before, this case is actually a conductor of the transistor. It's one of the legs. In this case, it's the collector. And if you don't have this little pad here, as you can see, which is just a thin piece of mica, okay, it's a glass-like substance almost, and basically this is very conductive of heat, and the paste helps to couple kind of on you know, the little pores in the metal and so forth, to totally couple the heat from the transistor to the mica pad, and then once again more grease down here transmits the heat from the mica pad onto the aluminum of the heat sink. Now this is electrically an insulator, but thermally a conductor, if that makes sense. So it's a thermal conductor and electrical insulator all in one. And the grease is the same way. The grease is thermally conductive, but it is not electrically conductive. Okay, it's an insulator. And the reason we're doing that is if all these transistors, these collectors are isolated from one another, okay? And when we looked on the schematic, you can see that. If these were all attached directly to the heat sink, it would be like putting a dead short between these collectors, okay? And the aluminum heat sink would become would become a conductor. So that's why we're doing all this, okay? Now, that being said, you can see this stuff is starting to get dry. I mean, I can still move it with my finger, and you can see it's still somewhat wet, but it is starting to dry out after all these years. Okay. Now, when these things are used a lot, and they're heated up, you know, that's what they do. They get hot. Eventually, the moisture will dry out, and then the heat sink paste becomes less effective. Now, because this amp, I can tell, was not used very much, everything is still in pretty good shape. But because we're in here as preventative maintenance, it would be crazy not to just go forward and replace the grease on this. Now, again, I'm going to show you my process for doing this. And again, if this is too tedious and so forth, just skip through this part, because I'm going to try to go through how I do it so that anybody who has not done this before may have a better idea of how to do it. Okay, so let me get some things moved around and we'll be right back in a second. Okay, we're back. So the first thing that we're going to do is we're going to clean off this mica pad. Now, once again, it is very, very brittle. If you bend it, it will crack and it's ruined. Okay, so it may already have a crack in it. You don't know, because the grease needs to be cleaned off. So alcohol works really well to break down this grease and clean it off effectively and easily. So the first thing I do is I get these blue paper shop towels. They're very nice because they don't make much lint, and unlike regular, you can use regular paper towel, but these are just a bit stronger and a little softer abrasive, and they just hold up better cleaning this grease. So the first thing you want to do is put a little bit of alcohol on one of these, and I hold this thing down like this, and I just kind of wipe all that grease right off, and then I turn it around and I wipe the grease off this end. Okay, then we flip it over and we do the same thing on this side. Okay, okay, and when we're done, it's clear. Now you can see on the edge, this is the part of the mica pad that was exposed outside the transistor, and so it had a lot more air hitting it, and because of that, because we had a lot of air hitting it, and I'm losing my battery here on the camera, so if it drops out, I apologize. So if you notice here, this didn't wipe off. It's because it has hardened, and you have to really scrub at it to get it to come off. And you can see if you really scrub, it comes off, but the reason it's on there is that showing what I'm telling you is that it dries out. Okay, it had more air hit it, so it dried out. Eventually, when you run these under heat, it will completely dry out, even inside here, and then it becomes less effective. Let me swap out the battery here. Okay, we're back. Had to do a battery change on the camera. Alright, so as you can see, after a little bit of scrubbing, you can even get the edges cleaned off. Alright, and again, the whole transistor area will get like that after these get old. So it is important when you're doing an old receiver to exchange the grease like this, to re-grease these. That'll mean, you know, another 30 or 40 years you can run this thing once you do that. So here we go. Now you can see this tiny little bit of a crack around the screw hole there. That's not bad, and it won't hurt anything. But if you get any major cracks or flaws, do not use this. Get a new one, okay? But these are reusable for those of you who do not have any spares. Now the other thing you could do is you could replace them for new ones, alright? So let's see here. They're hard to pick up. So as you can see, here's a brand new one I have. Alright. And this is just a regular mica pad, and you can see it's very clear. I'm going to just reuse this one because it's still good. But another option, and I want to show it to you guys, is these here. Now, these are silicone greaseless pads. Now, they have the advantage of, when you use these, to see they're flexible. They're made of silicone. They're same properties. They're conductive of heat, but they're insulating against electrically. So they're electrically insulators and thermally conductors. Okay, so they're a thermal conductor and an electrical insulator. Now, these are nice because you don't need any grease. There's no mess. You stick them on, and they never dry out. They never change. They last pretty much forever. Okay, and a lot of people are going to these now because they are pretty good. In some instances, I use these, but you have to remember, you know, there are different schools of thought with this. In my experience, I believe that the mica pad with properly applied, and that's the key word here, properly applied grease, does a little bit better job of thermal transfer than the silicone, just because of the coupling between the metal and the pad itself. You can see these pads are textured, and if you screw them down tight enough, they do make very good contact. But I do think, you know, in critical areas, and in areas where the transistors aren't going to get super hot, I'm sure they will work perfect. And I've used them many times. But when you're putting it in this instance, you know, these amps get really hot when you're running them at full power. I think the grease in the pads still is a better way to go. And again, everybody has different opinions about that. There's people that'll tell you they've used the greaseless silicone pads with very good success on, you know, big circuits. And you know, that's true. You probably could. But you know, this is the way I learned it. This is the old tried and true. And you know, for big amps and things, I still use the grease method. On maybe a lower powered amp, like a 50 watt, when you're using a big transistor that can take the heat, just to save time and mess and not have to deal with it again, then I'll use the silicone ones. So we're going to clean all this off with alcohol. The other thing is, do neat work. I hate when people put so much grease that it smushes all around and gets all over the heatsink and looks messy. Alright, so let's get the grease out and we'll be right back. Alright, so this is one of many different types of heatsink compound. I found that this stuff is pretty good, and you can usually buy it you know, online. There's lots of places, the electronics stores. I'm sure eBay and Amazon and all those will have this, but this is one very popular one. This one is silicone. Now, there are different compounds. Like when you're doing microprocessors, they run at extreme temperatures. They can get very, very, very hot compared to these transistors. And there is better thermal conductive compounds than just plain silicone. Some of them even have silver in the paste, and they're highly, highly coupling, conductive properties. They're very good. But for this purpose, this is what's always been used on these amps, and this works really well. It lasts a very long time, and if applied correctly, it will really couple the heat between the heatsink and the transistor and the pad. Now, let's talk about how much we put on, okay, because that's really important. If you put too much grease, it becomes the opposite. It starts becoming an insulator. It's too thick, and it takes too long to wick the heat through that thick layer of grease to the pad, and then through another thick layer of grease to the aluminum. So you want to have enough to fill in all the little inclusions in the transistor, and you can see there are a lot of little inclusions in that metal. You want enough grease to fill that in, but you don't want so much grease that it actually builds up a layer, okay, if that makes sense to you. So let's just put this grease on here and see what I'm talking about, okay. So I just take a little dollop like this, and you can put it onto the mica pad, or you could put it onto the transistor, whichever is easiest. So that's it. You just put a little dot, about that much, and then I just take this, and it's not harmful. If you get it on your fingers, you just have to clean it off. It doesn't hurt you. It's just silicone. But I try not to make too big of a mess. So basically, you just want to get it smeared on there. I want enough of a coating that you can't see the silver through the transistor, but not so thick of a coating that it's looks like a thick layer. So we take that and we just kind of spread it, and now once you push this pad on, it's going to kind of squish it around, and you can see how that's turning completely white for the most part. And as we put pressure on it, it'll actually spread around even more. So there we go. Okay, so that part's done. We then take another little bit, and we put it here on our heatsink. All right, not rocket science. And again, we spread it on here, just like this. Okay, and that's it. Simple as that. Now, normally what I would do in this instance is I would take these transistors out one at a time. I would either put them on my curve tracer, or I would just put them on my little transistor tester, okay, depending on how crazy I want to get with this. And before I mount them up, I would just take note of each one, make sure these transistors are, somewhat matched. So you can turn it on and, test it. And you can see this is one of the PNP transistors. And you can see our current gain is 77, and that's one of the things we want to take note of. These are going to be very similar, okay? So you have your 0.6 volts base to emitter. You're drawing 4.81 milliamps, okay? And there's no leakage in the transistor. So this is a good transistor. But the big thing is the beta is 77 on it. And I would go through, especially like on the Macintosh and some of those older amps that do not have a DC balance adjustment, okay? And there goes the phone. All right. So anyhow, what I was saying was I like to go through and I would test all the transistors, especially the amps that do not have a DC balance. DC balance allows you to do a little bit of compensation for the differences between the transistors, but which this amp has that. In some of the older amps that do not have that, matching your transistors makes a huge difference in your distortion characteristics and the performance of the amp. So I would take them all out and I would at least check the beta on them, try to match them up a little bit, and try to get them paired up as similarly as possible. Okay. So anyways, that's just a little bit on that. Again, it's not super critical because the range that they run these transistors in most good, well-designed amps, you're not really getting near the areas where that gain's going to make a huge difference, but it does make a little difference, you know. So anyhow, that's enough of that. But anyhow, this one's running beautifully, so I'm not going to even bother matching the transistors because I know they're pretty well matched and everything's good. But I'm going to go through and finish doing all this for all 8 transistors, and that's just how we do it. And when I come back, I'll have everything assembled, and we'll just do a quick sound test, you know, and then we'll decide what we're going to do next from there. Because I'm really going to kind of do some listening and some performance evaluation before I decide whether this amp really needs to have a full recap, you know, whether I would want it, if it would benefit from that or not. So we'll check that as we go. All right, we'll be back. All right, I thought I'd just take this quick second and show you. This is one that's really an example of what I was trying to talk about. This one here is kind of dried out, and you can see how much heatsink you can see versus the grease. It's dried out, and there wasn't a whole lot of grease applied. So this is why you want to go through and do this on these old amps. It's you know, when we're done, we'll have really a lot better coupling for this transistor to this heatsink, and you can see just how opened it is. There's not a whole lot of grease on there. So I just thought I'd show you that real quick. Okay, the receiver is back together now. I got the heatsink all reassembled. I have the board back onto the heatsink. I have the transistors reconnected, and now what we're going to do is we're going to end this video right here, this part 1. So our initial checkout and our little preventative maintenance of the amplifier is done. When we come back on part 2, we're going to rebuild the power supply here and test it, make sure it's putting out all the proper voltages. We'll then do a quick little bias adjustment to make sure the biasing is correct, and then we'll end up part 2 hopefully with a little test video where we'll actually test the amp and see how it performs and how it sounds. We're not even worried about the tuner section yet or anything like that, just basically how the amplifier performs, how the tone control section works, just see how you know, the highs and lows sound through this amp, and kind of get an evaluation and get a feel for whether this amp is a candidate for a full recap or if it's good how it is. So I hope you liked this part of the video, and again, give us a thumbs up if you liked it, and we'll continue this with part 2. So for right now, have a wonderful day, and we'll catch you on the next video.